Hi, Steve here at the SJCOE Fab Lab, where we are super excited about February the 18th. Why? Well, because there's a rover that's going to be landing on the surface of Mars. But we're so excited that we're having this NASA landing party. Now, a rover is a robot that goes out there and does science. We build a lot of robots here. Here's one with Legos. We can use lots of stuff to make a machine. We can design, draw out our ideas, and start building something. I happen to have some cardboard here, some tape, and a couple of other items, like sugar-free lifesavers. You might have some of this stuff at home too. This is from a lesson designed by NASA and JPL. You can find the full lesson here. Let's try out building this rover and see how far we can get it to go. Very important, safety first. You should wear safety goggles, because we're going to be using scissors. Okay, here we go. This NASA model rover is relatively simple to put together. The front axle is provided by a pencil, and the wheels are those square pieces of cardboard. The back axle is provided by a straw, and its two wheels are lifesavers. Everything is held together with tape, and the power for this device is provided by two rubber bands tied together. All right, let's try it out. Go wind it up, give it some potential energy. It's doing pretty well. Let's see how far it can go. Okay, kind of cool. Not too bad. I bet you can do better. Let's ask some questions about rovers, robots in space, from our friends in NASA. All right. We are so thrilled that we have here with us Ed Marie Sanchez-Herena, who is an intern with NASA, and she's going to answer a few questions that we have about Perseverance. Thank you for being here, Ed Marie.
Thank you for having me, Stephen.
So, I've got so many questions about this awesome robot that's out there, or will be out there really soon, doing science experiments. Could I ask you another question? Why does the rover look like a car and not like a person? Like I don't know. When I think of a robot being on another planet, I think it would look like sometimes I think it would look like a person. Why does it look like a car?
So two main things, stability and locomotion. So the rover uses a 6-wheel rubber buggy suspension system that was inspired by the suspensions used on railroads, cars for decades. And this system was developed and first used on the Sojourner rover. I don't know if you have ever heard of that. It's SOJOURNER, that's the rover. And so the advantage of this system is to keep the rover body stable because of the uneven terrains. And another thing is that it spreads out the rover to 2,260 pounds. And we need something that prevents the rover from getting stuck. The Martian surface is really sandy, and we need something that is good in suspensions.
So just to be clear,
part of the question. Yeah.
You said it's how heavy?
So 2,260 pounds.
So it's pretty big.
You could say so, but I believe that it's pretty light. If you compare it with a car. So yeah.
Okay. Cool.
The second part of the question, what it doesn't look like a person. The robots are shaped based on their mission. So this smart mission, the car is a type of car form, and we believe is more functional than having a type of human robot rover. I don't know if you have ever heard of the robot Naut. That's something that NASA has been doing with GM, I believe so. I'm not sure about that, but yeah, we believe that it will be more easy and more functional to have that type of robot human type on in and around the ISS. However, due to the constraints and like parameters that we could say that the Martian surface has of these uneven terrains and that we're still exploring, we believe that having this type of suspension system is better for this exploration.
Oh, that's awesome. Those were great. Those are great answers. Thank you so much for explaining those to us. We also have some answers from Brenda, who was an engineer working on Ingenuity. So let's see some of her answers to some of the questions that we had. NASA engineer Natalia Perez was kind enough to record answers to questions that we posed to her. Let's hear the answers. Can you talk a bit about the Mars helicopter research that your branch does?
In my branch, we're very excited about helicopters on Mars. And some of the areas of research are flight dynamics and controls to ensure that the helicopter can fly successfully. Another area of research is vehicle design to explore future optimal design for Mars vehicles. And we also perform computational fluid dynamics, which is basically simulating in a computer the helicopter flying. And finally, we perform experimental testing to validate these computational simulations.
How big is Ingenuity?
Sure. As we discussed before, it's a coaxial helicopter, and the rotor diameter is around 1.2 meters, and Ingenuity is about half a meter tall, and it has sensors for navigation, it has cameras, it's charged with solar energy, and it recharges on its own. It has all that with only 1.8 kilograms of mass.
What is the future of Mars rotorcrafts?
The way we see the future is that Mars rotorcraft conducts science in a way that has never been done before, by reaching locations that are currently inaccessible, traveling longer distances to allow for faster exploration, and carrying science instruments and payload that can provide meaningful insights and information about Mars. The way that my team and I, through the ROMEX project at NASA, are working to make helicopters capable of performing this is by optimizing rotor blades. We computationally optimize rotor blades, and we experimentally test the aerodynamic performance. We're interested in blades because this is where you can get one of the most significant improvements in aerodynamic performance to make all this a reality. Thank you, Steve. Thank you, everyone. It's been very fun and a real pleasure and honor to talk to you. Thank you very much. Muchas gracias a todos.
That was so much fun. I really enjoyed learning more about NASA and their projects, and who knows, maybe you'll make the next robot that does something amazing that we all need done. Keep on learning, keep on creating and drawing and sketching and coding. Have fun.